This
First,
conference will now be recorded.
we'll be starting with our first tool in our course, version control systems. Okay, what is a version control system? Why do we need a version control system? All of this. Let us talk about this now. How many of you know what a version control system is? Anyone using a version control systems? What is a version control system? Any idea?
Code checkout and uh, cloning the repositories.
Yeah, let us try to understand what a version control system is before we learn this. Yeah, version control system is nothing but which will help you maintain backup of your files, backup of your code. The files may be your program files, it might be some test scripts, some configuration files, whatever it is, right? So this version control system helps you have a backup of your files, backup of your and also maintain the version of your files, right? It will help you manage your files securely. Okay, to understand this better, let us take another simple example. Let's suppose there was a project. Okay, there were like a lot of files in this project. Let's say developers have written so many program files. These are all program files. Okay, they were all kept on some remote location. And yeah, they were not using any version control system, and there were two developers, developer A and developer B. So at some point of time, let's say both developer A and developer B need the same file, file 1. Okay, this is some remote location. Now both of them got this file downloaded to their local computer. Okay, developer A got this file. Similarly, developer B also downloaded this file. Now person A is making changes here, right? Developer B is also making changes. And after, like on day 1, developer kept this file back on the remote location. Remote location means where everyone can access. Developer B kept this file back on day 2. Okay, this is happened on day 1. This is on day 2. So now, okay, both of them have placed their file back, they placed their changes back. Now this file 2 on the or else file 1, sorry, both of them got the same file. Okay, let's say it's a file 1, not file 2. So both of them got the same file. So they kept the file back. Now the file 1 on remote location will have which person changes if they didn't use any version control system. Which person changes will be there on this remote location?
B.
Obviously, person B changes, isn't it? Because what is happening here? Person B changes are getting overwritten, right? I mean, person B is overwriting person A changes. Correct? Yeah. This is what is happening. B doesn't know that he is overwriting person A changes. Similarly, A doesn't know that his changes are being overwritten. Right? And so this keep on continuing. If this keep on happening, let's say with a team of 10 people or whatever, at some project, at some point, the project goes into messed up state, corrupted, right? So how can we overcome this problem? How can we avoid multiple people working on the same file? How can we handle this? That's where comes version control systems into picture. Means a version control system is one which can help allow people work simultaneously on the same file. And you may be asking, okay, it's only used by developers. No, anyone can use it. Let's say developers, yes, it's mandatory for them because they do write a lot of programs, right? It could be any programming file, Java program, .NET, Perl, PHP, whatever it is. Not only developers, right? It can be used by testers. Even testers do write some test scripts. Even ops teams uses it to manage their scripts, config files. Even DevOps team uses it because as a DevOps person, you'll be having a lot of Kubernetes configuration files, Terraform files, and so on, right? So everyone should know how to manage your files, right? How to version control your files. So that's what we'll be talking about here too, so that this version control system allows teams to collaborate well. Got it, everyone? So that's the first thing. And second thing is, okay, let's suppose, okay, they have a file 1, okay, and it's a version 1. Client came with some modification and asked them to make version 2. Let's suppose, okay, they have overwritten the same file and made version 2. the same file was edited and made a second version. Let's say after a few days, client want the version back, means they want to revert back to the previous version. But you have overwritten the same file, edited the same file and made a new version, right? So what is happening here? Again, you cannot maintain like versions to be maintained. How is that possible? Again, version control system comes into picture to maintain versions of the files. Don't ever delete the older versions. Maintain the backups, maintain the older version so that at any point of time, if you want to retrieve the previous version, that's right, right? So that's another advantage. Also to have backup of the files, to maintain the file safely, securely, and also to maintain the log of the changes happening. Means, okay, let's take a simple example. Today till 7:30 application worked fine. Okay, 7:40 application is not working fine. Okay, there was some drastic error, application went down. Like if that is happening, business goes down. We need to immediately put the application to the previous state. But how can we do that? We need a detailed logging. We need a system which can tell you, okay, person A made some changes at 7:35 p.m. right, on file 1 on line number 8, right? If you have this kind of detailed logging, you could revert back to the changes at any point of time. Am I correct? So this is another point, like this is another thing which version control system can do, right? So version control systems can maintain this kind of detailed logging, which is very important in reality. Can we do all of this manually without any tool? Yeah, we'll be working on requirements. As a DevOps person, we'll be working on so many other configurations, right? We cannot take care of checking if someone else is overwriting my changes or whether my file is maintained versions or not. So version control systems comes into picture. Everyone should learn this tool again, whether you are a developer or a ops person or a tester or a DevOps person, you should learn this version control systems. Got it, everyone? So whenever developer write the code, they place the code in version control system. So we'll pull the code, build it and deploy. Similarly, as a DevOps person, we do like in a project, we do have a lot of config files. Even we will maintain a separate version, a separate repository to maintain those files, right? That's the importance of version control systems. Okay, so now that we understood what a version control system is, let us talk about different types of version control systems. Right, based on the architecture, actually they were categorized as centralized version control systems and distributed version control systems. So let's see this categorization. So yeah, coming to the centralized version control system, yeah, you can see the diagram, right? Like I said, depending on the architecture, they were categorized. So as per the diagram, you can see there is one central server, this one, you may call it a central server or a remote server where all the where all the code base is kept, right? And then you have different, like you can see your working copy. These are nothing but the workstations of different DevOps person or developer, whatever you call them, right? So first we learn the version control systems with respect to managing our code base, managing our files. Then we'll learn to integrate it in the pipeline. Okay. So yeah, every person will have his workstation. So every person will connect to this remote repository or central repository, whatever you call it, right, and work on it. This is that's all. This is a simple architecture of central version control systems. And there are some drawbacks or limitations of this kind of architecture. Like the first limitation is you need to always have network connectivity, because you need to connect to the central server or remote server where all the code base is, right? So that's one thing where you need to have always network connection. And also, let's say for some reasons the central server is lost, chances of recovering that data is very less. Chances of recovery is very less. Means because it works like a single source of truth. If the data is gone, if the central server is lost, that's all. There's no backup there, right? So this is how centralized version control system works. Understood the architecture of central version control systems? Any questions on this part? Right? So I believe this is clear. So now that you understood centralized version control system architecture, let us talk about the architecture of distributed version control systems. Yes, any question from anyone? Okay, right. So yeah, here is the distributed version control system architecture. Here you can see, yes, this is the central server or remote repository where all the project, all the code base is kept. And every individual, every person, this is the workstation of each individual developer. Okay, this is the workstation. And if you see the workstation of each individual developer, they will be having another repository which is called as local repository. Means in distributed architecture, we'll be having two repositories. One is remote repository, the other one is local repository. Okay, now again, developer will not work directly on this remote repository. Okay, rather they'll be working on some other folder called as working directory or working copy. Means they make some changes in a folder, then move those changes to local. From local to remote. Means it's like a 3 steps before we move our changes to remote. Let's suppose changes are only in the local repository. They're only confined for me. Means as long as the changes are in the local repository, they're confined only for ourselves. Right? Making sense, everyone. So they're confined only for me. Only once I move my changes to remote, others can see the changes. Right? So this is the distributed architecture. Right? And here, yeah, coming to the drawbacks, you need network connectivity only to move your changes to remote once in a while, because majority of the times we work on this local repository, right? We make changes here, we develop everything. Once complete work is done, we'll push to remote. So working with the local remote repository is like we do more majority of the work here. We pull to we push to remote, get from changes from remote once in a while. So these are like pulling and pushing to remote. These commands are less frequent. Majority of the times we work here. So we don't need network connectivity. Even though network connection is disconnected, you can still continue working on local repository. Right? You need network connectivity only to push or pull to remote. So even though network connectivity is not there, entire work is not halted. You can still continue working. That is one thing. And another thing is, yeah, about networking. Another thing, yeah, let's say this remote repository is lost. Chances of recovery are more because everyone is having a copy of that remote repository, which is called local repository, right? So chances of recovery is more. Got the point, all of you? Everyone? Can I get a quick confirmation from everyone?
Yeah, Priti,
Yes, yes.
Right? So chances of recovery are also more. So that's how it overcomes the drawbacks of centralized version control system. And yeah, like I said, we'll be pushing or pulling, means we'll be moving our changes to remote or get the changes from remote once in a while, which are less frequent. Majority of the times we'll be working on our local system, means it also works faster. Right? You need to just access your hard disk to work on local. So this is the architecture of distributed version control system, and majority of the modern DevOps projects uses version control systems with this kind of architecture. Right? So it's a distributed version control system. And what are distributed version control system? Yes, our Git falls under distributed version control systems. Git, Fossils, Mercurial, all this comes under distributed. Then what are the examples for centralized version control systems? SVN, TFS, Fairforce. These are the examples of centralized version control systems. Got it, all of you? Clear, everyone? So
Yes.
yeah.
Yes. Yeah.
And yeah, because like I said, distributed version control systems are used in majority of the modern DevOps projects. That to Git. Git is very widely used when compared with any other version control systems. Is the architecture clear for each and everyone? Any questions, you can feel free to ask me. If you want me to repeat anything or any questions, you could feel free to ask me. Okay, that's about distributed version control system. And yeah, see here. This is a report from Google Trend Reports where you can see comparison of Git with respect to other tools. Okay, you can see the blue graph is for Git, which shows Git is a market leader. And also one more thing, if you know Git, working with any other version control system is as simple as that. You don't need to learn all the tools in the category. Okay, you need to master one tool under each category, like Git under version control system. Because if you know one tool, working with any other tool is easy. Also, majority of the projects are using it, so you will be like having great job prospective. So yeah. And then yeah, now that we understood like what a version control system is, centralized version control system architecture, distributed architecture, now let's talk about the architecture of Git in particular. Of course, yeah, this is distributed architecture, and like we discussed, yes, it will have two repositories, the remote repository and the local repository. Okay, so if you look into this local repository, yeah, again, like I said, they don't directly work on local. Okay, they'll be working directory. It's nothing but like another folder or else another directory. Okay, if you are Linux person, you may consider it's called directory or folder for Windows guys. So it's another folder. So you make changes here. Again, after making changes in a particular directory, it's not that you are just moving them to local straight away. We'll be moving those changes to first to staging area. What is the staging area? Staging area is nothing but some virtual layer, a virtual area. Okay, it is also called as index area. Okay, staging area or index area. From here, the changes can be moved to local repository. Right? It's not straight away. Like it's a two steps from working directives to staging, from staging to local. You cannot just do this way directly from working directory to local. No, that's not possible. Right? So I repeat, staging area is nothing but a virtual layer. It's also called as index area. Okay, first you need to move your changes to index, from index to local, and from local to remote. Remote will be shared across multiple people. So once you move your changes remote, everyone else can see your changes. Right? See, don't worry, we are going to see this practically today. I'll show you what is staging area, what is working directory. We'll see all of that in practice today. Okay, just understand first. I'll show you in few minutes. And yeah, again, you may be having a question like, what is the importance of this index area or staging area? Why do you need it? This is also important from the point of interview. So listen each and every point carefully. Okay, there's a question from Sumit. Any specific use of the staging area? I mean, why the need of staging before local? Yeah, yeah, that's what I'm going to talk about. That's what I'm saying now. So, what is the importance of this staging area? Yeah, this staging area works like a preview or else pre-check before your changes goes to local. You may say it like preview or else pre-check before you have a go to local, or else you may say like it is to have a better control on what changes are going to local. Okay, what changes you want to move to local. So that's a kind of a preview. Okay, so let's suppose in a working directory, suppose in the working directory, let's suppose you have some changes here. Okay, let's say there were some 10 files in the working directory. Okay, I have some 10 files here. Okay, I just want only 5 files should be placed in the local repository. Okay, only 5 files in local. So you will move only those 5 files to staging area or index area, a virtual layer. Okay, so whatever in staging area only will go to local. So you are having a better control on which changes will go to local repository. Am I making sense? Hope I answered your question, Sumit. Okay. Right. So that's the importance of staging area. How is the staging area? How to create? We'll see that. Okay. Just give me a few minutes. First, let me explain here all the points. Then we shall talk about it. Now coming to this remote repository. Like what is this remote repository? Right. Remote repository is nothing but your GitHub, Bitbucket, or GitLab. All these works like a remote repository. Means remote repository is nothing but where you can host your local repositories and share it with others. Okay. So yeah, you can host your repositories here. Now here let me tell you few important things. Okay. Yeah, we were talking about local repository, right? How to create this local repository? There were two use cases how you can create this local repository. One use case is, okay, you joined the team today, you joined the project today. Already there is a remote repository. It's some 2-year-old project. Already there is something on remote. So you can copy from remote and create a local repository. Okay, that's one use case. Another use case is, let's say the project is a new project. Okay, you join the team today. There's nothing on remote. Okay, you can create an empty local repository, develop your changes. Maybe it might be a developer's repository, it might be a DevOps repository, whatever it is. Okay, here I'm explaining the concept. The files could be anything. So create an empty local repository, develop the code base here, then push to remote. Right, this is another use case. So it can be created in two ways. We will get started with this scenario first. Means assume it's a new project, so we will create an empty local repository, put the files there, then move to remote. Then we'll also take up the other use case. First we'll start with this second use case. Understood how local repository can be created? Is this point clear for each and everyone?
Yes, Preeti.
Right. So that's a two use cases how local repositories can be created. Okay, and another very important point to note here is, yeah, come back to this architecture. Yeah, we were talking about, yeah, you have working directory, you have a staging area, you have local repository. Here, the very important thing is they are nothing but directories, I told you, right? This working directory, this local repository is one and the same folder or the same directory. Then why are you saying it is working directory local repository, isn't it? Yes, it is one and the same directory physically. Logically, they are different. How they are different? What is meant by that logically different? Let me tell you. See, this is a folder or a directory. Okay. If I just placed a file there, I have created a file by writing it or by copying it, whatever. If I just placed a file in this directory means, then we call it as a working directory. The same folder, let's say the folder name is my repository. Okay, so if I have created a file, then I'll say the file is in the working directory. Suppose then if I add the file to staging area by running commands we'll learn later. Let's say if I add it to staging area, okay, or index area, just let me give you a clue. Okay, then we call it as it is in the staging area, right? Then let's suppose if I commit, means if I move that to local repository, then we'll say it's in the local repository. But physically the file is in the same folder. Do you notice it? File is in the same folder. So the folder name is my repo, means my repo is the working directory. The same my repo is the local repository. Got it, everyone? Physically it's the same one and the only directory. Logically it's different. It will be really very interesting to learn Git if you learn it properly, if you understand the concepts thoroughly. Yeah, clear with the concept? It's the same folder, yes, working directory, local repository. Now you can overlap. Here I'm showing with two different boxes. Now you can overlap them. Both are same, one and the same directory. If you just place the file means you call it, it is in the working directory. After creating a file, if you move it to, or if you place it in the staging area, then you say it's in the staging area. What is meant by placing in the staging area? How do you do it? By running git add command. Okay, then if you put it in local repos, then we say it's in the local repository. Right? So these are the interesting and the important points you need to make a note of. You need to memorize. Watch the recording once again, okay? Because it's a lot of information there, right? Lot many important things we have covered. I have covered almost everything about the architecture, in which you may be having the interview questions like what is the staging area, what is its importance, okay? Why do you need to place them on the remote, how remote the repositories work, for basic questions on Git, right? These are the basic questions on Git for maybe 1 or 2 years experience people. So if you are clear with this, we shall go and install Git and start with the hands-on. Okay, this is how we learn any tool. First learn what is the use of the tool, who uses it, the architecture, and then install the tool and learn the tool. Good to go? Right. So let us go and install this Git. Now coming to installation. Git works on multiple operating systems. Git works on Windows, Git works on Linux, Mac, Git works on multiple operating systems. So only installation differs. Okay, the concepts are same, the commands will be same whether you use it on Windows or Linux or Mac, whatever it is. So first let us install Git and start with the hands-on on Windows. Like I said, only installation differs, right? So how to install it? See, don't save the links, okay? You don't just go to the same link and learn the process. Like you just type in here, git download. Okay, you will be seeing some Git official documentation, which is gitscm.com. Just go here. And here you can see like download a Git for Mac or Windows or Linux. Okay, how to do the Git installation on Linux also we will see in the coming up classes. Now we shall go with the Windows. Okay, just click this. When you click this, you will see an executable downloaded. Okay, in exe here you have the links. You can click on it so that the exe downloads, and you have to run the exe. That's all. It is as simple as that. Installing Git is very simple, particularly on Windows and all. It's very simple. So I have already installed Git. I cannot show you downloading the exe and run the exe, but you have this documentation available on the Google Drive. For all the registered students, you might have already got this documentation. Yeah, this is the drive I would be sharing with the registered students. I have already shared with the registered ones. If you just go to this folder, you have a document called Git installation on Windows. You have everything including the screenshots here, right? Like you could see here, Git installation on Windows, go to Git SCM, just download the exe. It's very simple. Okay, download the exe and double click the exe like you install anything on your Windows. You will be navigated through the wizard where you need to just click on next and continue. That's all you have to do. Just keep on continuing next and continue. Right? See, just give next, 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 and so on, and click on finish. Finally, Git will be installed, and along with this you will also have Git bash installed. Okay, Git bash is like a command line tool through which you can work through which you can work in your Windows. Okay, just click on next and install it. See, this is what you will see at the end. So once it is installed, you can just go to your start menu run the command git bash. Okay, this provides you some bash environment where you can run the commands. Okay, this is what you will have, right? So just follow this document. Everything is there with the steps in this documentation. Okay, you can go through it and install it. Okay, if it is Mac also the same way you can install. Yeah, here you can just go to Mac, click on Mac, simply brew install git will do. Just run this command from the terminal, brew install git will do. Okay, right? Simple as that. How can I access the Google Drive? For all the registered students, I have shared it, Shrikant. Once you register, you will get access to the Google Drive where you will have all the documents, all the presentations. Okay, so fine, git is installed. Now, if you want to check the git version, git ---- version will do. Okay, so yeah, now you can start version controlling or using it. Okay, before that, let me tell you one thing. Yeah, we are working on Windows right now, right? As we progress, we'll be working on Linux environment. Both are same, okay? It is just you need to get with the new familiarity with the new operating system, that's all. The only difference between Linux and Windows will be this GUI. Linux systems will not have this graphical user interface. Majority of the works happens from the command line. Anyway, it's not a big deal learning Linux. It's just learning working with another operating system. That's all. You need to know simple commands which you can learn just by using it. That's all. Like you are working in Windows, if for a few days you work on Linux, you will be used to it. That's all. So here in Linux, everything will be done from the command line. So for our practice, let us also do the same. Okay, let's say I just want to create a local repository. Okay, you can just go and create some folder. In Windows, how do you do that? Right click and you may just go and create a folder, right? But how do you do it from the command line? In Windows also, do it from the command line so that you will get a practice of working on Linux environments. Yeah, if anyone new to Linux, this will help you. So I just want to create some folder. And where do you want to create some folder? I just want to create some folder on this desktop. Okay, you may just go to your desktop, copy this address. Now I want to create a folder, but I don't want to create from the UI. So from the command line, you may use your just the terminal you may use, or PowerShell, or else git bash, anything is fine. So to go to desktop, how do you do that? CD, okay, the path. Okay, see here you can see now you are in the CD is a simple command. That's a simple Linux command. That's how you can learn Linux commands daily, few commands daily. That will help you. That's all. Okay, so go to that folder. Now create a folder here. How do you do that? mkdir. This is another command. Okay, make directory, my repo, or whatever name you want. So at the back end you can see. Can you see that you have seen created a folder? See, if you feel it like you don't know Linux, that's fine. You can just create, go and do this way. But if you just want to practice, follow this. Slowly anyway, maybe in a week or two, we'll get used to this. So just slowly get started, or else you can also do it from GUI. That is also perfectly fine. Okay. So, okay, fine. I have a directory. Let me open this. So this is how you go. Then how do you do that in the command line? Like I said, CD, change directory, this directory name. Now I am in this directory. How do you know in which directory you are in if you don't have GUI? Commands, pwd, present working directory. Those are the simple Linux command. Anyway, we'll have a separate session for Linux. This is just to give you some comparison between GUI operations and command line operations. Okay. So yes, now I am in this my repo. Yes, now I want to make this as a local repository. If you recollect, some time back I told you how to create a local repository, right? How to create a local repository? There were two use cases I have explained, right? One is you copy from remote and create it, or else you create from you create an empty local repository. First, let's do that. Assume it's a new project. Okay, so I just want to create an empty local repository. This one should be my local repository. So, okay, now I have installed Git. I want to tell Git to version control a particular folder, or else I want to create a local repository. So whichever directory you want to make a local repository, go to that directory. I want to make this my repo as local repository and run the command called git init. Then this my repo becomes the local repository, and Git will start version controlling any files present in this local repository. Got it? So what you should do, git init. Then yes, you can see here at the back end, you can see, do you see at the back end in the GUI .git, a folder is created. Here also it says the same, initialize empty repository, means empty repository is created. Now any files present in this folder will be version controlled by Git. Okay, got it? Understood all of you? So now if you want to version control any files, maybe you may create any files here, maybe C program files, Java files, or Terraform files, or config files, whatever it is. We just need some file. Okay, we are not bothered about the content of the file. So any file will do, or simple text files will do. So I'm going to create a simple text file, new text file. No, actually I just want to create a simple text file. Just let me go for okay, I'm just creating a text file. I'm just writing some dummy line. If you want, you may write any configuration files or programs, whatever you want. This is first file, let's say. Okay, if you want to save it, go to file and save it. Okay, where do you want to save? I just want to save it in the my repository. Okay, let's save it. Okay, some name, let's say file1 dot file1.txt, right? So I have some file created. So is this file now being version controlled by Git? Okay, how do we know? Let's see. And by the way, let me ask you one question. Where is this file now? Of course, physically it's in my repository. Logically, where is the file now? Yes, where is this file? I have just created a file. I told you, right? If you just create the file, means where is the file?
Working directory.
Exactly. See, always relate it with this architectural diagram. Keep this architectural diagram in your mind. Relate to it and you can. Yes, it's in the working directory. Okay, fine. Let's say I don't know where it is. Okay, how can you identify where it is? You could run a command called git status. Git status command will tell you the position of your files. Okay, so just run git status. See, come here. Untracked file means yes, Git know there is a file, but Git cannot track this file. Git knows there is a file, but it cannot track it. So nothing added to commit, but untracked files are present. It cannot track it. Then what is it saying? It's giving a clue. It is asking us to add the file so that Git can track it. Means now is it clear? Where is the file? It is asking us to add. Means where is this file now?
The working directory?
Exactly, it's in the working directory. It is asking us to add. Because it's in the working directory, it's not being tracked by Git. Git know there is a file, but Git is not tracking it. So what you should do? Yeah, that's what saying untracked. What you have to do? Git add that file name. Run the command. Now check the status. Now if you check the status, yes, now it clearly tells you changes to be committed. Can you tell me now where is the file?
Staging area?
Exactly. It is in the staging area. Okay, that's how you put it in the staging area. You run git add file name is staging area. And it is asking us to put it in the local repository. So what should I do now? Git commit -m. Git commit -m flag for some message. Okay, like let's say some message for later. When you refer later, you can understand what this file is all about. Okay, so git commit, right? So you could see, right? Can you see that? So now you could see here, yeah, git git status, right? So you can see here as on branch master. Got this, everyone? Yeah. It was all clear. Means now the file is in the local repository. You could also check another way. ls means it will list the files in a directory. Git ls files will list the files in the local repository. Now because the file is also added in the local repository, you could see it this way. Got it, everyone? Is this much clear for all of you? Yeah.
Yes, Preeti.
Right?
It's
So
clear.
let us repeat this with another file so that it should be clear for all of us. Yeah. So yeah, we have a file one. Okay, let me create one more file, right? You may also create with Linux commands this way, touch or else Vim editors you can use. We'll talk about them later. I just created a file. You can see at the back end, okay, file is created. I just want to put something like hi into it. I'll explain touch echo commands later, okay? Separately we'll learn those commands. Just create some file. Now tell me, where is this file to? ls will list the files. Git ls files will list the files in local repository. See, do you see the difference? File 2 is not there. Do you see that? Yeah. Okay. So now what shall we do? Git status, what would be the message git status shows us? Untracked files. Do you see that? Untracked means the file is not being tracked. It was in the, where is the file to?
Working directory.
Working directory. Now you have to do file 2 dot, right? Add the file. Now can you tell me where is the file? What would be the git status message telling us now?
It is in staging.
Yeah, git status message will tell you that. Yeah, can you see that? It will tell you that. And it is asking us to change this to git. So commit the changes. Git commit -m, let's say second file or something like that. This message will help you for later reference to understand what this commit is all about. Right? So git commit. Yes, now the second file is also added into the local repository. Now ls shows both the files. Git ls files will also show you both the files. Right? Right? Understood, everyone? Yeah. So that's how it works. That's the architecture of Git. Right? We'll do lot many things. Okay. You can remove some files from local repository. You can remove from staging area, undo the command. Lot of many things are coming up. This is the basic concept. Yeah, tell me please.
What is the difference between ls and ls minus? It's both the
Sorry?
same or different? Here writing one command ls minus files and ls files. ls
ls will show the files in the working directory. It's a Linux command. Okay.
Linux
Git
command.
files will show the files in the local repository. Only once they are added and committed, then only they'll be shown here with git ls files. Got it?
Okay, man. It's clear.
right? And yeah, so till now we have made some commits, right? So to see the history of commits, you have log command, git log. We have done twice, right? So what each commit command will do? Commit command will generate a hash code like this, which is unique for each commit. It will generate this. See, do you see author and all? I didn't put any name, so it was showing like this: author, the timestamp, the commit message. Commit message in real time could be a reasonable message like, okay, terraform config file change, something like that, so that at a later point of time when you refer, you can understand, okay, this commit is about making changes to Kubernetes file or config file and so on, right? And if you want to just see a simple, a brief log, git log, one line, a simple log, instead of showing you everything, a brief log. So for a brief log means only first 7 characters of this commit ID are enough, and then the commit message, right? Those are the simple log commands. Git is very simple, only the thing is practice, hands-on, thorough hands-on is important. See, these are the commands. This is where we started. History command will give you all the command list: git init, git status, git add, git commit, git ls. That's all. Those were repeated. We did that for 2 files. Got this concept now? Understanding this architecture is very, very important, because at times in the real projects you may be stuck up managing the file. Sometimes your file may not be editable. Sometimes it might be like you might be seeing a new commit. You want to know who made this commit, right? Or else you may see some changes gone. Who made these changes? All of them you want to see, right? Some other person might have deleted some changes. You want to see those changes, or else you may want to get those changes back whichever were deleted. So to do all of these operations, you need to understand Git thoroughly. This architecture is very important. We'll be doing all of those things, okay? How to revert, how to commit, how to see the changes and all. Actually, we started like this is the beginning, and like I am just doing the changes. There might be multiple people, right? How to handle that also we'll see. First understand this architecture and the concepts. We'll go through those use cases as well. So this is a local repository. See, this my repo is a local repository. The same my repo is also a working directory, right? Physically it's the same. Logically it's different. And yeah, if you are not comfortable using the command line, the Linux commands, you may also create the files, everything from the GUI. That's also perfectly fine. Okay. Yeah, till now we created new files, but in the practice it's not, it may not be always new files, right? You may have to edit the files at times. So how to edit any file? Like how to edit the files, isn't it? Like when you edit, what happens? Let's see. Let me just edit this. Open with the notepad. Okay. I'll also show you how to use a better editor later. For today, just let's say I just want to make a change. This is a new line, some dummy line I'm adding. I just want to save it. Okay, done. Now I made a change. What will git status tell us? See, it was giving a different message. It was not saying untracked file, because file is already there in staging area, only the modification, right? Correct? So if it is just a modification again, so you need to stage the modification. So what you have to do, see, remember one thing, Git always works with respect to changes. Change means the change may be creating a file, the change may be deleting a file, the change may be modifying a file. Okay, so what you have to do, you have to do git add the file name, and this is what you have to do. Or else, because it's not a new file, any question from anyone? If you have a question, unmute, otherwise having a background noise. Any question, you can unmute and okay, because it's not a new file, you could also add and commit in a single line this way. -a means add and commit. If it is a new file, you have to do them separately. If it is not a new file, you can do either ways. Now I can do either ways because file 1 is not a new file. It's not an untracked file. For the first time, if you remember, it was showing this message as untracked. Do you remember that? It was showing like untracked, but now it was showing like unstaged. That is another difference between untracked changes and unstaged changes. When do you get an untracked change? If it is a new file. Unstaged means file is not new, only some changes were there in the working directory. Okay, you can add and commit. So I can either do add and commit separately or else with a single command. Which one shall I go with now? Shall I go with this method of doing it separately or this one? Anything can be used now because it's not a new file. Which method we shall go with? Let's commit with A and M because we didn't use it before. Modified some message. A means add and commit. Okay, done. Now if you see the status working tree is clean means whatever changes you have, they were all added and committed, right? And you can see this file 1, the new change is there. Okay, cat will show the contents of the file, or else you may open this way and check the contents whether they were saved or not, right? So that's about the basic way of managing your files through Git. How do you place it in the staging area, from working directory to staging area, from staging area to local repository. And remember one thing, we didn't go to remote repository yet. Okay, we didn't go to remote. We are still on this local repository, on this here. We didn't go to remote. We'll go to remote. Okay, but before pushing our changes to remote, there are many other things we have to do on local repositories. Okay, then we shall go to remote repositories. So we will be learning Git and GitHub completely till the till the advanced concepts. So maybe it may take some 2 to 3 days, 3 days more. So yeah, completely 3 days dedicated for Git to learn it thoroughly. Any other questions you have from anyone? So now what I'm expecting from you is you have to do the hands-on. Whatever we have done, it's just very few commands, hardly 10 commands, right? Just practice this much and join the class tomorrow. Means before you join the class tomorrow, please complete this hands-on, right? Can you do that? Complete the hands-on. Also watch the recording once again, because we have discussed about the architecture and all. I want everyone to be thorough with that, so that you could answer all the interview questions will be shared with you. You should be able to answer them. So watch the recording, go through this hands-on. Any questions you could post it in the group, right? And yeah, we shall continue from here in the next class. As it's just day 1 of hands-on, we shall stop here and we'll continue from here tomorrow. Anything else from any one of you? Any more questions? In a couple of hours, you will get the class recording. First day recording was placed in the YouTube. The same I'll also place it here. You will also provide I'll provide the recording. Actually, SDS recording was already shared, and from today recording will be shared for all the registered students. I have registered but no email received regarding recordings or WhatsApp group. Can you let me know your email ID and your contact numbers for now? Whoever registered, I have shared them. Registered means you need to complete the payment and enroll to the course. If you have done that, let me know. You could ping me on WhatsApp. I'll share you the details. All right then. Yeah. Any further questions or anything you have, you could reach me on my number. Swarna, can you just ping me once again now? Yeah, please ping me now. Okay. Yeah. All right then. Bye everyone. See you all.
Thank you, Preeti.